My name is Dmitry Chaplinsky, and for last, I don't know, 10 years I'm Python developer, and I visited every single PyCon since 2012, I believe. And even today, it was yesterday, a lot of people came to me and shook my hand and like, "Hi, Dima," and I was like, "Who the hell are you?" And it's got more and more strange with every single year. In addition to my daily job where I get my money from, I also have a secret life, and I'm working for two initiatives. First is the White Collar 100, or канцелярская сотня украинскую. Switch to English. Yeah. So White Collar 100 is an NGO which works with data. The crucial component of our life is data. We are collecting data, we are opening data, we are creating products, tools for journalists, activists, even law enforcement bodies using this data. And we are managing gigabytes of data already, hundreds of gigabytes of data already. And another initiative is Lang UK. It's our common effort with Vsevolod Demkin, who was a major guy at Grammarly at the time. So we are trying to improve the position of Ukrainian Ukrainian natural language processing by collecting the data, training the models, and putting it all under the public domain, putting it all online. And in this project, we worked with a lot of data, terabytes actually of data. But today, I will try to show you not the code, not the technical side, but I will try to go with three stories, which I hope you will find enjoyable and inspiring. Well, maybe 4 stories, who knows? It depends from the time we have. But yeah, the next thing today is lunch, so I would try not to tire you too much. And by the way, just today I read an article about Jeff Bezos' latest email to the board, where he said PowerPoint is no more. PowerPoint is not the thing. Instead, we should do a narrative. Instead, on our board committee meetings, we should circulate well-prepared 6-page document which explains, in plain English, with noun and verbs, the story, and then everyone took 30 minutes to read it silently and then discuss. I think someday we should try it at PyCon. Just imagine how it changed everything. But the main point here is the narrative. Unfortunately, I'm actually still using PowerPoint today, so unfortunately we are going still with slides, but I will try to make it more like stories. But let's start with natural language processing. Natural language processing is a set of algorithms and nifty ideas how to extract some meaningful information from the raw textual data, from the natural language, using computer powers, using computer algorithms, using machine learning models, you name it. And why it matters so much? Because, the internet is made of mostly 3 things. It's cats, porn, and text. And, well, I had a joke about this one. I haven't had it in the changed presentation because host said you can't use Stoya photo on this slide because it's we're violating the code of conduct. So instead of this, I put his photo there, but this presentation, it's on Google Slides, so with this internet, it doesn't work. Okay, so texts. Why text matters? Because there are plenty of text. I mean it. If you know the project called Common Crawl, which actually download the whole fucking internet once a month and put it online, you can see that even on their front page, they say, okay, we have petabytes of raw textual data, which you can download. The monthly batch is roughly 3 billion web pages and terabytes of data, and I once downloaded it and processed it. It was a very nice exercise. But we're speaking about Ukraine and Ukrainian language here, so let's look at Ukraine. For example, over the last year and a half, the size of Ukrainian Wikipedia grew by 30%, which is pretty nice, growth rate. So let's switch to the first story, and coincidentally, it's about Ukrainian Wikipedia. So Ukrainian Wikipedia, and this is basically a story about search in different meanings. But let's start again with basics. Know that guy? Yeah, that's Peter Norvig, yeah. And Peter Norvig once said that more data beats clever algorithms, but better data beats more data. And in natural language processing, it's really like the cruelty of the world you are living in. You might have the perfect algorithms, but if you don't have data, you're screwed. And this is pretty much the case for Ukraine. I mean, for English, some universities are working for 30 years. Well, not 30, sorry, for hundreds of years, investigating language. Last 60 years, they are doing some research about computational linguistics and all that stuff. But in Ukraine, it's not the case. So if we are looking at the source of textual data, source of data that you can use with natural language processing algorithms, there are 3 of them. First one is universities, which I mentioned. And when I just started to work with this idea, I found some laboratories in different universities doing some research, and they announced that they really have some results. The problem with that results is that no one outside the university haven't seen them. I mean, maybe they don't even exist. And the only way you can like touch this data is you're going to work in this university like a assistant for like 5,000 hryvnias a month. Yeah, but you can like carry it outside. And when you go and say, okay, don't you want to publish the data which you actually collected using what? State money, state financing? And say, no, you will take my data and you will build a startup and you will be a millionaire or maybe a billionaire, and I will still be sitting there like having 6,000 hryvnias of salary a month. Of course, my point is, even if I'm not doing that, you're still sitting there getting this low pay. But well, the answer was like polite or impolite no. The other other source of data is business, and business collects a lot of data. For example, in Ukraine we have a Liga. You probably know Liga.net, the news website, but apparently this just a face. They have plenty of products, and they're working on textual data for 20 years now, and they've built a lot of really interesting products, but of course they're not giving away the heart of that products, the data in which they invested a lot of money. Sometimes business are quite responsive. I mean, Facebook are publishing their data and their algorithms in open source, but it's not the case for Ukraine yet. And the third one is this like smiling guy, Richard Stallman, which should picture the guy like me, like the volunteer who collected something or created something and put it online, like open source. And when I started to search for the data, I found magnificently through a beautiful girl, Marianna Romanishin, a Brown UK team, which actually creating some open source products by collecting and systematizing some textual data. And they have various applications, but we will talk about one single product today, the Morphological Dictionary, and it was created by this great man, Andrei Rysin, Vasil Starko, and these volunteers which also helped. So what is Morphological Dictionary? Morphological Dictionary is not a dictionary like we used to think of, like a huge dusty book. No, it's not at all. Instead, this is just a computer file which is generated actually, which connects lemma of the word, which is like basic form of the word, like singular, no inflections, and the word forms. Ukrainian language, like other Slavic languages, it's very rich about word forms. So for example, for every single Ukrainian word, there might be like tens or maybe 20 of inflections of different word forms. And this dictionary is actually quite good. It has more than 300,000 lemmas and more than 5 million word forms, and when you look at that, it doesn't look really sexy until you like, boom, what we can do about it, how we can apply this data, because so far it's more or less academic thing. And one of the applications is full text search. And when you are searching in the rich languages like Ukrainian language, and you can't like, okay, no one is constructing the search query like every single word form or so you're not trying to put the word in every possible inflection just to find the proper thing. You might search for eggs, and the document which mention egg wouldn't be found because, well, this is actually different token, different word, but they are connected. So this information encoded in this dictionary can improve the search. Of course, we are not talking about giants like Google, because they know their business and they are like well paid for that. But we are talking about the open source search. Sorry, have you seen this magnificent meme when the Mark Zuckerberg on Congress hearing, he was like drinking water, and the title said, "Excuse me, I need to lubricate my organs." Yeah. So we started with the idea, okay, we have a data, we can improve the search. We are using, in our project, we are using Elasticsearch quite a lot, because it's free, it's open, it's fast for our purposes, and it's feature rich. Unfortunately, I'm a Python developer. Well, fortunately, I'm a Python developer. Unfortunately, Elasticsearch is written in Java, and you can extend it with plugins, but it's also written in Java. I don't know Java, unfortunately, or fortunately. And friend of mine, Dima Gamble, who is also a Python programmer, unfortunately for him, he knows Java. And I like was knocking his door like, man, I have a weird idea. Let's do some Elasticsearch plugins, and I'll prepare the data, and you will do the code. And he's like, well, fuck you, but okay, let's do it. So he created a plugin which takes the data from the dictionary and creates an analyzer for the Elasticsearch, which at the time of indexing of textual documents in Ukrainian language, it converts all the words into the lemma forms if it's available, and it does the same during the search. When you're searching, your search request is converted to the lemma form, and then search result is apparently better. And we started to use it. It was a little bit memory hungry because the dictionary was quite big. And Dima maintained like 5 or 7 releases because for some strange reason, Elasticsearch requires to release plugins, re-release the plugins for every like major release of Elasticsearch, and he still maintains it. But my idea was like, okay, can we do better? Of course, we can do better because Elasticsearch is built upon Lucene. Lucene is like well-known library for the full-text search, and it's been on the market for 20 years. But it's a library. It's very well, not very, but it's low level. And Elasticsearch is built on top of that, not only Elasticsearch, of course. So I found another unlucky guy, Dmitry Chaplinsky, who also knew some Java, and he also an author of this dictionary and the programmer, main programmer of the Brook initiative, said, okay, Andrei, can we incorporate this data straight into the fucking Lucene? And he said, well, I will try it. And he is quite a good, like, professional, great Java programmer. I don't know, maybe, well, not something to be proud of, but still. So he created a component for the Lucene, and it was reviewed. There was a like lively discussion about that, and he got some interesting comments how to implement it. So it's not memory hungry, using nifty data structures like directed acyclic graphs or something. So it's like all this data, like 300 megabytes, was packed into 10 megabytes. And this plugin, not plugin, but class was included into the basic contribution of Lucene. And this was big because, well, Lucene is the like heart of the Apache Solr, another open source search engine. Elasticsearch and also Lucene is used by Twitter, LinkedIn, and even we are using it through the Elasticsearch. And because all of these products they are built on top of Lucene, they started to propagate this change, this support for Ukrainian language into the end products. But well, let's return to the Wikipedia. Why this part of the story refers to Wikipedia? In a month, maybe, someone sent me a link to the Wikipedia bug tracker, which says, track progress of Ukrainian analyzer in Lucene Elastic. It appears that a new Ukrainian analyzer should come out with Lucene 6.2. So Wikipedia uses Elasticsearch. And then, in a couple of months, test and analyze, another ticket appeared, test and analyze new Ukrainian language analyzer, because it appeared in Elasticsearch 5.1, I believe. If we do decide to deploy one, then back out whatever parts of the Ukrainian Russian hacks. So apparently, to improve the Ukrainian search in Ukrainian Wikipedia team used some algorithms and data for Russian language because they've been marginally better than going without them. And finally, in a month, like a year ago, deploy new Ukrainian analyzer and reindex Ukrainian wikis. That sounds like a really big update which should be really useful in improving stammer coverage. Boom! Yep. But this was story number one. The story number two, that scary picture again, is about universities. And you know, I'm usually telling this story when I'm drunk. I mean really drunk, like pub crawl after the PyCon. And when you're sitting in like 2 a.m., like, well, okay, and everyone is bragging about some achievements, and I usually tell in these stories. So this story about the universities, okay, and this slide has 3 photos, and I truly believe that these people never met in their life. The first one is a programmer, developer from Russia, and he was also a scientist, like true scientist, not like me. The other guy, he's actually a physicist. He's nuclear physicist, quite well-known guy in his area. He's from Ukraine. And the third one, this is a wife of the Deputy Prime Minister Kirilenko, and she's also Lepton Queen. Her name is Katerina Kirilenko. Well, I think no bells are ringing in your brains while I'm explaining that. Okay, then you will find it fascinating. Okay, but to approach this story, we need to go back to 2012. Nice time, like dollar was like 8 hryvnias. In 2012, no, man, I'm old. I do remember when dollar was like hryvnia and 96. Yeah, so great. Yeah. Okay, back in 2012, and I've started my journey to the natural language processing. And of course, my idea was, okay, can I use it for Ukrainian texts? And at that time, the situation was even more gruesome. Like, it was not nice at all. Like, no data, no work done. But instead, I found a guy in Moscow who actually developing a product which is free, which is .NET, which sucks, but it's free for use for non-commercial purposes. And he is working on the product which extracts the information from the raw texts, and information like people, place, products, organizations, law numbers, like license plates, dates, just from the raw text. And he managed to like build the connection in extracted entities. Like, okay, this guy mentioned in this sentence works for this company or group of companies mentioned in the next sentence, and it worked quite well, but for the Russian language. And I was bold and young, and I said, okay, man, I wrote him an email and said, okay, man, can you create something like that for Ukrainian language? And he said, well, I can, but well, I need the data. And I asked, what kind of data? And he said, I need a morphological dictionary, just like the thing I explained on a previous slide, but it wasn't created at the time. Instead, I found a couple of websites of the universities which actually had this information. So they created a website where you can search for the word and then look for the word forms, and it probably had like 10 visitors a month, and it was very, very unpleasant to use. I mean it. You should be like a really, really focused person just to use it as a customer. But of course, this data wasn't downloadable. Luckily, by the time I already had my like green belt in web scraping, so I wrote maybe the most ugly web scrape. Well, .NET websites is usually very non-pleasant to scrape, but this was like the top on the shit list, like number 1, then Gap, and then maybe Craigslist, whatever. So in 2 weeks, I got all the data and sent to him, and like forgot about it. And in 2016, we created the Landcore UK, Landcore QA, which is our initiative on the data, and we published some results. And I remembered that guy and sent him an email bragging like, man, we got some data, Ukrainian language, maybe you will find it fancy. And he said, oh, well, I will look it up. But more interesting, he said exactly that. То, что мы тогда с вами сделали для украинского языка, сильно помогло многим в дальнейшем. В частности, в рамках проекта Диссернет разработан сервис, позволяющий сравнивать диссертации на предмет наличия похожих фрагментов. Сервисом сейчас активно пользуются украинские активисты. And next to that, there was a link to Ukrainian Pravda blogs with the article from this nuclear physicist guy, which said, таким чином, незалежна експертиза виконана нами за допомогою спеціалізованого сайту Disser.com.ru, де перевірки співпадінь в російсько- та україномовних текстах підтверджує та доповнює висновки Тетяни Пархоменко щодо наявності плагіату в дисертації К.М. Кириленко. So you got some data, you open it, like you let it go, throw it into the river, and you never know what kind of application it will find. Maybe not a single one, but sometime it like really fascinating. And the third story, it's about Ukrainian registries and open data. Who knows where this screenshot is taken from? Ні, хто сказав DJ Shadow? Чувак, я зробив цей слайд для тебе. Well, actually this is quite a nice music video, and it been filmed in a Ukrainian house, and this guy sitting is actually Ukrainian actor. Like the story number 3 almost made it to the United Nations. But again, to give you some context, who knows what the beneficial owner means? What does the meaning of beneficial owner? Beneficial owner is actually a person who controls some legal entity, like company. And by controls, I mean the real owner. When you are a corrupted guy, and when you're stealing from the state, and you want to like make this money work for you, you create a company, but not under your name. You create like a chain of shell companies, one registered on Cyprus, one on BVI, one of registered on Guernsey, or maybe Delaware, and this makes it harder to understand who is the owner of this company. So for example, the guy who is sitting in the Ministry of Energy, and he lobbied for the changes in legislation to get better tariffs for the green energy. He then established the company for solar plants, but of course it's not established under his name, but he is beneficial owner of that company. So he is receiving the profit from this. And I just briefly explained why it matters, because sometimes it's really hard to find who sits behind some company. What is the real person, not just some poor guy from the Cyprus. Apparently, Ukraine is not doing too bad in that area. Ukraine became the second country in the world after the United Kingdom to implement the public register of the beneficial owners of corporate entities registered in country. And who of us is owning a business in Ukraine? Like, who is like a company, not a physical entrepreneur? Then, then you might be familiar with this little form number 4. So when Ukraine decided to collect the data about beneficial owners, the only way to understand who is a beneficial owner is to ask the company, like to put some obligations to provide this information and put some sanctions. But to collect this information, they created a paper form where you can type in, like, okay, beneficial owner of that company is me. And then state fiscal service, using state fiscal service crowdsourcing, turned that into machine readable data. Like, oh, sorry, I spoiled it. Like this one. Well, machine readable data, it's better than scanned form, and I can tell you. But there is a twist, because it was like the idea to run this was so fresh and hot, and they didn't have much time. They used the same the same tool, the same software for the registry to collect the data. And they did not create like the structure for this data in the database. Instead they used some kind of commands to each and every record in the registry to put this into the textual form. And they apparently instructed the SFS crowdsourcing how to put this data into the textual form. Well, I will show you why this is a problem a couple of slides later, but then in 2 years, Prime Minister Groisman said, okay, we finally opening this data. Like, this data was collected, it was barely available. When you file in like request for every company, you can get this data, but you can get it in bulk. They've published the data in the open data form on the open data website of the government. And also he said that we are joining the global registry of beneficial owners maintained by the United Kingdom company. So our data will join the global registry, and then everyone who is using this global registry, he or she can search for this data in the registry and restore the pieces of puzzle, pieces of this chain by using information from different countries. And of course, like always with promises from politicians, is very nice on the paper, but this is a cruel reality. And I like how this like, this is like the third possible, 30% of possible ways to spell beneficiary ownership from that registry. I mean, beneficiary, beneficiarny, benefit. So this is what is going on when you are instructing crowdsource people to enter some data into a machine-readable format. So the data was very noisy, and apparently, when they said we like opened this data for the open ownership, they just gave them away a dump from the registry, which wasn't parsed. Somehow they managed to find me and said, okay, man, you probably can help. Can you build a parser? Because we would like to present that on United Nations Assembly like meeting in September of 2017, and we need some results. And we need some results fast. And because I know some Kung Fu and this nifty algorithms to extract entities from the text, I said, okay, I will give it a try. So we've created, well, I created a machine which first just analyzed the text and gave me some mental image of the data that is stored there. Then I started with very simple approach. I found on the internet the list of Ukrainian names, like last names, first names, and built a quite simple heuristic to just look for that names in the data and to try to extract the chunks which follow each other. Like if there are 3 words in conjecture, I identify it like a name, last name, first name, and patronymic, that's probably a name. And that helped to parse like 75, maybe 80% of the data from that register, because it was very simple. Then I just get this data, and because I managed to identify the chunks, I then fed this data into the machine learning algorithm and build a model. And then build another one and another one. Then I've got this data and replaced the Ukrainian names with the names of like Greek athletes, German football team, German porno actors, and stuff like that, just to train some models which can identify not only names in Ukrainian language, but also names in other languages, because our registry has information about guys from Cyprus, Greece, Germany, United States, United Kingdom, you name it. This is how I managed to build like 15 different models using different chunks of data, using different word vectors. And then I created an ensemble model. When you are throwing the data at the ensemble model, and it uses all these different ideas, all these different models, heuristic model, machine learning models, and then combine their results, because some models are good at finding foreign names, some models are good at finding Ukrainian names, some models are good to find addresses, some models are good to find countries. Then all these results are combined, and most of this work was actually done before the September, but because negotiation with this United Kingdom company, which maintains the global registry, took too long, it only seen the light of day, I believe, in 2018. And this is like parsed record about the Mr. Poroshenko factory, Vinnytsky Kombinat Хлібопродуктів. And that concludes the short story. And of course, I can talk for hours, maybe, and I have some other stories in my pockets. Some of these algorithms, they actually used, and some models we trained and put online, they used to analyze the informational простір, the informational space of Ukrainian news. So, for example, if you're a company which is doing public relation or sociology, and you would like to know how some messages are received by the auditory, and how some messages are penetrating the news and media and blogs, you can probably use some name identity recognition algorithms to identify how many of textual content produced in last months is about the person of the interest. Of course, using the same idea, you can beat some, oh, it's lunch already starting. I can see some people like migrating to the restaurant. Okay, I will be like really quick because I'm also hungry and a little bit drunk. And this is actually used by the friend of mine who is running a startup to analyze the Ukrainian news and media and blogs to understand what are people saying about particular politicians. And if someone is running like black PR action against you, you can use these algorithms to identify what is the source, like which media they bought to publish the source of news, and which tools they use to then like spread the word. Like in some way, it's a tool to beat the fake news. Also, text took our data sets and some of my code and building their own pipeline to process texts. Do you know who the text is? This is like news website, which is well known for their infographics, and they are doing a lot of interesting things, analyzing very different aspects of Ukrainian life using the data science, actually. Using the computer vision, using satellite images. If you don't know, I would like to recommend you to go and familiarize yourself. And now they're looking into the texts. And the list goes on, and the major takeaway from this, the algorithms, the technical part, the programming job is already done. It's created for the English. It's created maybe 10 or 20 years ago, and it works quite well. The only component you need to make it work for the Ukrainian language is the data. And this is kind of like low-hanging fruit. You got some ready-made solutions. You add some algorithms, sorry, you add some data which you collected and prepared, and boom, you've got the result. And usually it's pretty good. So this is, again, low-hanging fruit, and which can yield quite interesting results. And that concludes my talk. I would like to hear some questions.
What's the name of the website you're talking about? Sorry, I missed.
I forgot to put it on slide, sorry. Any other questions? What's for lunch? Oh, please. You can yell. I mean, I'm...
For this first example of search, how different is actually search for Russian and Ukrainian, say for Wikipedia? Does it really like massively change the results, or?
Well, I didn't measure, but they've been quite satisfied with the results. And well, if you contact me on Facebook, I can even provide you links to their bug tracker, and you can watch. There are lively discussion, like 20 comments of people trying different options, and finally they decided to use our option. Yeah, please.
Have you taken part in USA presidential elections?
No, because I'm not a United States citizen. I can't run for the president in the United States.
So, for instance, you know, in Python you have this package Stacy that does like name entity recognition and stuff. Does it support Ukrainian, or like is there a package you would recommend that could work for this kind of thing?
See, we actually during the 2016 we found some data and we tagged it. Well, of course, sometimes you don't. The data is not enough. You need to add annotations to say, okay, this is what the group of people experts thinks is the name in this text. This is what is the company name and stuff like that. So we did that. We published the data set, and we also trained 2 different models using that data set. One is using SVM and open source library MITI. And to train it, we spent like two days, maybe 48 hours. Sorry. 48 hours on a very powerful server. So we put this model online so we can download it, put it into the free library, and get it work. More than that, one guy even wrapped it into the set of microservices, so you can like launch it in Docker in in the time which required to download the image from the Docker Hub. Also, I've created, for the previous PyCon, I created my own model using neural networks and all the fancy things I found on the market, like bidirectional, LSTM, board embeddings and stuff like that, and it worked pretty good. And I never published it because it was kind of raw code written in very, hackathon style, but I shared it with the girl from the Texty, and she is now trying to apply it to their data and then add our data and create their own models. And I would try to facilitate the idea that the result should be also published. Not only, by the way, not only for Ukrainian language, but also for Russian language.